going to tell you the rotation in radians. Everyone know what radians are, right? 0 to 2 pi around a circle in radians. Look it up if you don't know it. And that's also telling you velocity in radians per second, how fast the person's rotating. Swipe gesture is one of these discrete gestures. You just set up this swipe gesture, you allocate it with the target and the action, and then you set these properties: direction or number of touches required. Number of touches means this is a swipe with 2 fingers or 1 finger. That's what number of touches means. 2 finger, 1 finger, 3 fingers, 5 fingers, whatever you want. And the direction is left to right, right to left, top to bottom, or bottom to top. Okay? So you create it, and then if a swipe happens that meets all that, you'll get your handler called once with recognized as the state. Does that make sense? So a swipe is something you don't track. It just tells you, oh, I saw a swipe. And yes, it's smart about if you have a pan gesture recognizer and a swipe gesture recognizer, if you swipe smoothly enough, it'll see it as a swipe. But if you go slower or you don't go across, you're going in a diagonal or something like that, it'll say, oh, no, that's a pan. Okay, so it knows how to kind of tell the difference between gestures, okay, as much as possible. It's pretty cool. Tap gesture, just like swipe gesture, right? It's discrete. You set it up, how many taps, double tap, single tap, how many fingers, etc. And it'll send you recognized when it sees it.
Can you do swipe gesture recognizers 4 corners, or no? Or is it only those 4 directions?
The question is, can you do swipe gestures like you mean like swiping up into a corner as opposed to...
Right, or something like that.
I don't think so. I think it's just left, right, up, and down. I could be wrong about that. I haven't looked in the documentation for a while, but I think it's only those 4. All right, so let's do the demo. Okay, it's just going to be, I'm going to go faster. This is a lot to show you here, okay, but I'm only going to show you all the things we just talked about today, but I'm going to try and show all of it to you in a comprehensive demo. Let me talk about what's coming up so that we can just finish the demo and be done. Again, we're hoping on Friday to get this University Developer Program thing going, but it looks like that's still not working. Watch Piazza tomorrow for whether Friday is canceled. At this point, it's not looking good. That would be a Stanford only thing anyway. The homework, as I said, is due a week from Monday, so more than 7 days from now, a week from Monday. I really strongly recommend you get started on the part that is a custom view and gesture recognizer immediately. Do not wait until next Tuesday or Wednesday, because then you're going to find that this is a lot of work for this assignment to try and jam into 1 week. That's why I've given you, however many days it is. Do this part. I would try and do this part before next Monday if you can, but certainly do this part as soon as possible. Then the rest of the part, which is animation and auto layout, which I'll be talking about on Monday and maybe next Wednesday, you can leave that. You can do that after you do this part. They're not so intertwined that it's like, oh, you got to do them all at the same time. It's something you can do after. Okay? Okie dokie. So we are going to create a new project in Xcode here. And I'm going to call it, I'm going fast through a lot of these starting up things because you know how to do this already. So I'm going to call this one Supercard. One thing interesting here, I'm not going to specify a class prefix just so you see what that looks like, because we've always specified that like card game or something like that. So I'm just going to not specify that, and we'll see. I'm going to create it in my home directory developer as I usually do. Here you can go and see right here where it says viewController.h and viewController.m. That's the name of my view controller classes, which is really, those are bad names. And that's why we usually want to put something in that class prefix, like card game view controller. Okay? I'm going to move these down out of the way. Otherwise, here's my view, right? My storyboard view. And I could bring up the controller for it right here. You can see I've got a view did load, which I'll go ahead and leave. Memory warning, don't need that. Okay? And all I'm going to do in this view, it's a little smaller, is put a single view, custom view, which is going to be a playing card, but a real playing card, drawn playing card. Okay? So let's start by doing what we always love to do, which is setting our background here to moss. I love moss. There it is. Okay, there's our moss. We like that. I'm doing that mostly so you can see what's going on better. And then I'm going to grab this custom view out of here. So let's go down here. UI view is pretty far down, past halfway. There it is. See right here, view represents a rectangular region in which draws and receives events. And you just drag it out. put it out here. I don't want it to be this big, so I'm going to make it smaller. It really doesn't matter exactly what size I make this, because I'm going to make my class, my drawing class, so that it'll draw properly in pretty much any size. Now, it's going to look pretty bad if it's not, you know, mostly tall than wide, because playing cards don't look very good if they're wide and short. Okay, my view will work. People won't recognize it very much as a card, but it certainly would be fine. And in your assignment, the custom view you're going to create, you also want to make it that way so that it works in any size bounds. And in that card, since it's going to be a set card for you, set cards actually could make sense being sideways. You would want the three symbols, you know, going sideways instead of up and down. So a good solution would make really any aspect ratio look nice for a set card. But playing cards, mostly only going to look good kind of set up. So what we do here then is we go to this identity inspector, and here we want to set our class of this view to be some custom class, right? Right now it's just a generic UI view. And so let's go create that class. So I'm just going to do File, New File, just like we always do to create a class, Objective-C. This one's going to be a subclass of UI view, okay, instead of UI view controller or anything else. I'm going to call it Playing Card View. Okay, this is going to be a generic playing card displaying view. Completely generic, not tied to the Machismo model, not tied to anything else. It's just like standalone. And remember that when we create views, things that go in the view camp, they want to be as generic as possible and reusable as possible, so that I could use this playing card view in my poker game app and also in Machismo. Okay? That's why we really want to try and enforce that kind of generic nature of it. So here's playing card views implementation. You can see that I've got init with frame right here. That's its designated initializer. And you can see I've got the all-important draw rect commented out. If you comment this out and you don't put anything in there, that's going to be a performance hit, because it's going to think this view needs to be redrawn all the time when in fact it doesn't. So that's why it starts out commented out. But we are going to draw in here, so we will be commenting it out. I'm going to move this. We're going to do something in there, but I'm going to move it down out of the way because we're going to do that at the appropriate time. Okay, so anytime we create a new class, really important to think about its public API. So let's do that. Let's look at its public API. It's a view, right? What does it need to do? Well, this playing card needs to display, playing card view needs to display a playing card, so we better have some way of specifying which card we want. Now, some of you might say, oh, great, let's use card star, or playing card star would be great, because playing card star's got everything we need. But again, I don't want to tie this generic reusable view to that model. So instead, I'm going to have NSU integer rank, and I'm going to have NS string suit. And I'm also going to have something that's not even in that other model, which is non-atomic bool face up. Okay, so I'm going to have, so my card is either face up or face down. This is a playing card view. It's got to be able to display the card in either up or down. So that's my API. That's all I really need. And so we just got to implement that API in our implementation. One thing I'm going to do right off the bat is this. Okay, now I typed this really fast. Whew, that was it. All I'm doing here is all the setters for all my public API, I am calling setNeedsDisplay. Okay? Because if someone changes the suit or the rank, and yes, I could say if underbar suit does not equal suit and save myself a setNeedsDisplay, but okay, demo time here. So I'm doing setNeedsDisplay just to make sure if anyone changes the rank or the suit or the face-upness of my thing, I tell the system I need to be redrawn. Do you all understand this, why I do that? Okay, excellent. So let's dive into drawRect here. I'm going to uncomment it out. Okay, and start drawing here. Now, if I'm going to do all my stuff with UI Bezier path. Well, actually, no, I'll do a context here just to show you the context. We'll do it a little later. But we're going to start off doing UI Bezier path. And let's start with the outside of my card, which I want to be a rounded rect. Right? I want my cards to be a rounded rect. So I'm just going to create a Bezier path here, UI Bezier path. I'm going to call it, let me make some more space so we can see lots of code here. Rounded rect, I'll call it. And I do that with UI Bezier. Actually, there's a class method that does that. Rounded Bezier path for rounded rect down here, this one. And I'm going to have that rounded rect be as big as possible. So I specify self.bounds as the rectangle to draw this rounded rect in. Okay, self.bounds is my coordinate system. Its width and height is the amount of space I have on screen to draw in. Okay, corner radius. I'm going to throw in some magic code here for that. This is an important thing. This corner radius is how many points is in the radius as it goes around the corner of the rounded rect. And really that number depends on how big my card is. If I have a big card, I want a big radius. If I have a really small card, I want a really small radius. So I've created this corner scale factor, which I've just standardized to some height, and I can play with these numbers to see what works for all sizes. And then I'm going to pick a radius that at this height is 12, and that works pretty nicely, right? And then I'm going to scale it. Okay, so I'm going to call this method right here corner radius. Corner radius. And you'll see I'm going to use that scale factor in other places too to try and scale it up. And this is part of what I'm talking about. You need this thing to draw in any size bounds that makes sense. So you're going to have a little bit of stuff that is dependent on, you know, the size and height of this thing to pick the right size rounded rects and things like that. So the first thing I'm going to do with this rounded rect actually is I'm going to clip to it, because I don't, add clip. I'm going to, I don't want to ever draw outside that rounded rect. Okay, that's the interior of my card, so I'm just going to clip to that. It also lets me do something like this: UI color, white color, set my fill color, and then I can just, sorry, I do that a lot. Then I'm just going to use this C function, because I just want to show this to you. UI rect fill, and you specify a rectangle, self.bounds. Okay, this just fills this rectangle. So it's kind of like shorthand for creating that path, filling it and all that stuff. It just fills it. It's a nice little UI kit thing. And this is going to make a big rectangle, but this clip is going to keep the white of this on the inside of that rounded rect. So it's not going to draw the white in the corners up there. However, I've got a problem here in that my background color for this view is by default white. So it's doing this all on a big white rectangle that includes those corners. So I need to stop my background from being white, and I also need to tell the system that my playing card is not opaque. Okay? So I'm going to do that in init with frame down here, but I'm going to do it in the right way, which is to have a setup method. And in setup, I'm going to set my background color to nil, which means I don't draw a background for me. And I'm going to set opaque to no. I'm not opaque. I'm also going to do that content mode equals UI view content mode redraw. Remember I told you that if my bounds ever change, I want to get my draw rect called. Now my bounds is not going to change in this demo, but I know that if it ever does, that's what I want. And then really importantly, I want to make sure I do this in awake from nib. Okay, self setup, because in fact, in this demo, I am going to be creating this view in a storyboard. I'm not doing alloc init on it. So this is how I'm going to get set up. Okay, question?
What's the advantage of setting background color to nil instead of UI color clear color?